Okay, calculus people. Today we are focusing on one question, and that is when to natural log antiderive and when to do other antiderive. So hopefully by the end of today, we will be able to know when to natural log antiderive. And these are the two that we're really going to focus on because these are the ones that you're going to see. Something that looks like this. Okay? So notice in the top example, we have a cubic on the bottom and a square on the top. Okay, the denominator has a larger power than the numerator. In this situation, you're going to be thinking about the natural log antiderivative. Okay, trying to create a 1 over u situation. Okay, when we have the denominator that's bigger than the numerator. Now, the one on the bottom, notice that the numerator has a greater power than the denominator. So we're going to have to do some algebraic manipulation before we can take this antiderivative. So this is going to be a long division question. Long division. Okay? So when the numerator has a greater power than the denominator, we're going to long divide, and when the denominator has a greater power than the numerator, we're going to try and make a natural log antiderivative. Okay? So let's start with the top one. 1 over u. That means we're probably going to want to do some u substitution. So let's let u be this entire denominator, right? We would like this to be a single equation. That's where we want our u to go. So if we let u be equal to x cubed plus x, then du equals 3x squared plus 1 dx. So then dx is du divided by 3x squared plus 1. Okay, so hopefully u substitution is something that you are familiar with doing. Right, you are confident in taking the derivative of something and then solving this for dx. So now we're going to do our substitution and we're going to replace our two values with what we've got here. So this is going to be 3x squared plus 1 over u, right, here's your u, times du over 3x squared plus 1. Hopefully we can see that the 3x plus 1, 3x squared plus 1, and the 3x squared plus 1 do cancel each other out. They divide to give you 1. So we're left with the integral of du over u. Okay, so memorize this one. The antiderivative of 1 over u is the natural log. Okay, so we are taking the antiderivative of du over u, and that is the natural log. So we don't have any more integral because we have anti-derived. And when we take an antiderivative, we get the integral away. That's what the integral is telling you to do. So when you do that, the integral is gone. And our last step is to replace u with x cubed plus x, because that's what we said u equaled. And then, of course, our plus c. Sorry, I am forgetting my constant of integration. Okay, because we're not evaluating this, we're going to have an equation as your function. Okay, let's contrast that type of a problem with this one, right? The numerator is definitely not the derivative of the denominator. Even if we did some u substitution, wouldn't help us at all. Right? So we're going to use long division to try and eliminate as many of these fractions as we possibly can. So in long division, you put your x minus 1, right? This is your divisor outside of your dividend. Now we have an x cubed minus 2x squared plus 0x plus 3. When we do long division, we need to have every x accounted for. So our question has an x cubed, it has an x squared, but it doesn't have an x term, so you have to remember on your own to put your x term into your equation. You need to remember to do that. And now the process of long division. We ask ourselves, self, what do I have to multiply x by in order to create x cubed? The answer is x squared. So we put what we have to multiply by in the correct column. So here's our x cubed column. Here's your x squared columns. There's your x column. There's our number column. Keep things in the correct columns. Now we have to multiply both of these terms out here by x squared, giving me x cubed minus x squared as my product. And now we subtract. Subtract, so this becomes a plus because minus a minus is a plus. X cubed minus x cubed is gone. Negative 2x squared plus x squared is negative x squared. And we'll drop down our plus 0x. And we'll do it all over again. X times what is negative x squared? The answer is negative x. Okay, so if we have a negative first term, then we're going to have a negative or a subtraction in your problem up there. Okay, so now this is now a negative x that is here. And when I distribute, I get negative x squared plus x, because minus a minus is a plus, right? Negative x times negative 1 is a positive x. And now I subtract. So this changes this sign to a plus, and that changes my second sign to a minus. X squared minus x squared is 0. This is negative x, and I drop down my plus 3. And I ask myself again, x times what is negative x? And the answer is minus 1. And now we do our multiplication one more time. We're multiplying all of these things by minus 1. So minus 1 times x is negative x. Negative 1 times negative 1 is plus 1. And we subtract. So this first term becomes a plus, and my second term becomes a minus, and my final answer is 2. Okay, so we have done some algebraic manipulation to change our equation. So all of this whole entire equation has now been changed to this stuff plus 2 divided by x minus 1. Okay, so let's write out what our new equation is. Our new equation is x squared minus x minus 1 plus 2, the remainder, over x minus 1. So now let's take the antiderivative of each of these pieces separately. Okay, so what is the antiderivative of x squared? X cubed over 3. Minus, what's the antiderivative of x? X squared over 2. Minus, what's the antiderivative of 1? That's just x. Plus, what's the antiderivative of 2 over x minus 1? Okay, this is our natural log situation. That's the natural log, right? Where x minus 1 is your u. So this becomes 2 times the natural log of x minus 1. And of course, there's going to be a plus c. And that's your entire answer. X cubed over 3 minus x squared over 2 minus x plus 2 natural logs of x minus 1 plus c. our constant of integration.
Are these questions usually like FRQ?
Okay, let's change gears here and look at a couple of more of these natural log things, right? The equation of the tangent line at the point 1 comma 0. Okay, so here's your x, there's your y. So all we need to find is your slope. And how do we find the slope? That's the derivative. Okay, so we need to find the slope, which is the derivative. So if y equals natural log of x cubed, what is the derivative of natural log of x cubed? That's 1 over u, which is x cubed, right? So whatever your u is here becomes your new denominator, and then we multiply it by the derivative of x cubed, which is 3x squared. Okay, so that's our natural log derivative, 3x squared over x cubed. What can I reduce? 2 of these x squareds with 2 of those x squareds. So I had 3 on the bottom. I got rid of 2 of them. That means I have 1 left. So now, what is my y prime when I plug in an x value of 1? 3 over 1 is 3. So I have a slope of 3. So to write our equation, y equals the slope, which is 3, times x minus the x value, which is 1, plus the y value, which is 0. So in other words, we don't have to have that plus 0. The y equals 3 times x minus 1 is sufficient. Okay, here's our next example, another equation of a tangent line. We have to find the slope, so we take the derivative, plug in 1, and then write it as our equation. Okay, how about we do some calculus? So notice, how have we defined our function f? F is defined as a integral from a number to a function with another variable, right? So this is a t, that's an x. This should alert you that we are using what calculus concept? The second fundamental theorem. The second fundamental theorem. We're taking the derivative of an integral, right? Derivative of an integral. Which means we simply take our integrand, right, your upper bound, and you plug it in for t. So 2 times the natural log of 5x times what is the derivative of natural log of 5x? 1 over 5x times 5 plus 7. So all of this is our derivative, right? We have to replace your t value with your equation, and then you multiply by that equation's derivative. Okay? So this orange stuff is the derivative of natural log 5x. It is a chain rule if our upper bound is anything more than just x. Okay, we have to do the chain rule. So let's do some simplifying. I have 5 times 2 times the natural log of 5x, which is 10. Natural logs of 5x divided by 5x plus 7. Okay, so that is the whole entire thing written as a single fraction, plus 7. In fact, that would be an even better answer with the 2 natural logs of 5x over x plus 7. Very good job. Okay, here we have ourselves an equation with two variables, and we're going to find dy dx. Do you remember what this one was called? That's kind of what I figured. This is called implicit differentiation. We're going to use implicit differentiation to find dy dx in terms of x and y. So we want to have x and y in our answers. So one at a time. What is the derivative of x cubed with respect to x? 3x squared. Plus, what is the derivative of 2 natural log of y with respect to x? 2 over y times y prime, right? So anytime we're taking the derivative of a y, we automatically get this y prime, which is the same thing as dy dx, by the way. I like using y prime because it's less fractional, less writings, but dy dx and y prime are the same thing. Okay, plus, what's the derivative of y cubed? 3y squared times y prime again. Very good. Equals, the derivative of a constant is 0. So now we want to solve this equation for y prime. So our first thing is, move our 3x squared over here as a minus 3x squared. And our next thing is to factor out y prime from both of these equations. So 2 over y plus 3y squared equals negative 3x squared. Our last step is going to be to divide by all of this stuff. Okay, divide by everything in parentheses. So y prime equals negative 3x squared over 2 over y plus 3y squared. Okay, so we have our dy dx in terms of x and y. And we're done. Okay, let's see what we got. Okay, so we're going to take our derivatives. Hopefully we're picking up on this right. So y prime is 3 over x. And y double prime, okay, I'm going to change this to be 3 times x to the minus 1 minus 3x to the minus 2, which is negative 3 over x squared. So now let's come back to here. Is x times 3 over x. That's not y double prime. That's y prime. So x over 3 over x squared plus 3 over x. Does that in fact equal 0? That's what we want to find. So this becomes negative 3x over x squared plus 3 over x. Okay, so we can simplify this by dividing one of these x's out. Negative 3 over x plus 3 over x, those do in fact equal 0. So in other words, this function is a solution to this differential equation. Okay, so here's a little more help with natural logs. Hopefully you feel more confident about our natural logs than you did when we started. Okay, have a great day in Calculus World. Goodbye.